The ground beneath your feet feels permanent. Yet hidden almost 5,000 kilometers below it, a solid sphere of iron has been quietly changing the way it moves. Scientists did not discover this by drilling into Earth or watching the core directly. They found it by comparing earthquakes separated by decades. The evidence was so subtle that it appeared only after thousands of kilometers of rock had carried the same echoes through the planet, again and again, across an entire generation. At first, the claim seems impossible. Earth feels like a single, solid body. Mountains rise, oceans shift, continents drift over millions of years, but the planet itself appears fixed beneath every step we take. If anything deep inside were moving independently, surely we would have noticed long ago. But the first clue did not come from the core. It came from something completely ordinary. Earthquakes. Every large earthquake sends vibrations racing through the planet. Some waves skim along the surface, others dive downward, passing through the mantle before entering Earth's metallic core. They continue through the very center and eventually emerge on the opposite side of the world. Most disappear into the background of scientific archives. A few become something far more valuable. Some earthquakes occur in almost exactly the same place, years apart. Their size is nearly identical. Their waves leave along almost identical paths. To a seismologist, these are repeating earthquakes. They create echoes that should be almost perfect copies of one another. If Earth has not changed along that path, those echoes should arrive at the same time. That expectation held for decades. Then it didn't. Researchers comparing earthquake records from the South Sandwich Islands with recordings made in Alaska noticed something unusual. The waves traveling through Earth's deepest interior no longer lined up perfectly. The difference was tiny. Only a fraction of a second over a journey lasting many minutes. Yet only one group of waves behaved this way. The waves passing through the inner core. Everything else matched almost perfectly. The mismatch was written directly into the ink lines of old paper seismograms and the digital traces recorded years later. The surface portions agreed almost exactly. Deep inside the record, one arrival shifted. It was as though the path through Earth's center had quietly changed while everything above it remained the same. That observation transformed a stack of earthquake records into something unexpected. A window. The inner core is impossible to visit. No instrument has ever approached it. Temperatures rival the surface of the sun. Pressure exceeds anything humans can reproduce for more than brief moments. Direct observation simply does not exist. Yet the earthquakes had carried information there and back. Earth itself had become the measuring instrument. The more scientists compared repeating earthquakes, the harder it became to preserve the old picture of a completely rigid planet. The simplest explanation was no longer that Earth was perfectly fixed inside. Something at its center had shifted. That hidden object is remarkable even before it begins to move. Earth's inner core is a solid sphere made mostly of iron and nickel. It is about the size of Pluto. Despite temperatures hot enough to melt ordinary metals, the crushing pressure keeps it solid. Around it lies a vast ocean of liquid iron, slowly flowing under enormous pressure. Unlike the rocky mantle above, the inner core is not physically attached to the rest of the planet. It floats inside liquid metal. That single fact changes everything. If the surrounding liquid and Earth's magnetic forces gently push on the core while gravity pulls in slightly different ways, then the inner core does not have to rotate at exactly the same speed as the surface. It can slip. Not dramatically. Not violently. just enough for decades of earthquake echoes to notice. The first interpretation suggested the inner core was rotating slightly faster than the rest of Earth. Scientists called this differential rotation. The difference was astonishingly small. The core gained only fractions of a degree each year relative to the surface. At that pace, the motion is almost impossible to imagine. A hidden metal sphere, moving so slowly that centuries might pass before it gained even one extra turn compared with the mantle above it. Nothing about this resembled the dramatic headlines that would appear years later. The planet was not coming apart. Its heart was simply moving on its own schedule. As more decades of earthquake data accumulated, the picture became more complicated. Some researchers examined additional earthquake records stretching across more than half a century. Others turned to an unexpected source: underground nuclear tests from the Cold War. Those explosions produced seismic waves from precisely known locations, offering another way to compare signals passing through the inner core. The evidence agreed on one important point. The core was moving independently. But exactly how it moved became the new mystery. Some observations suggested a slow cycle, lasting many decades. Others hinted at shorter oscillations. Different datasets emphasized different rhythms. The disagreement was not about whether the motion existed. It was about the pattern hidden inside it. One recent interpretation proposed that around the late 2000s, the inner core's motion relative to Earth's surface slowed until the two briefly matched. After that, the core appeared to drift slightly slower than the mantle. The phrase core reversal quickly spread through headlines. It sounded alarming. It was also misleading. Nothing inside Earth suddenly reversed direction like a mechanical gear. The entire planet continued spinning through space exactly as before. The change existed only in the tiny difference between the inner core's rotation and the rocky shell where we live. From our perspective on the surface, the core's gradual lead disappeared and then slipped slightly behind. The distinction is small. Scientifically, it changes everything. Emotionally, it changes the story. Instead of imagining a catastrophic event hidden beneath our feet, the evidence points towards something quieter and far more remarkable. Earth's deepest interior behaves like one component of a layered machine, interacting continuously with the liquid metal surrounding it. The consequences reaching the surface are extraordinarily subtle. Tiny variations in Earth's rotation may change the length of a day by mere fractions of a millisecond over many years. The forces involved also connect to the liquid outer core that generates Earth's magnetic field. Although the exact relationship remains an active area of research, the significance is not destruction. It is discovery. The same object introduced at the beginning of this investigation has changed meaning completely. The inner core is no longer simply a hidden ball of iron buried beneath thousands of kilometers of rock. It has become evidence that Earth itself is a dynamic system whose deepest parts can evolve independently, even while the surface feels perfectly still. Every earthquake that crosses the planet now carries another faint echo from that unseen world below. Not an echo of disaster, an echo of motion. And through those echoes, humanity discovered that the planet beneath every step has been quietly changing all along.